Okay, hello and welcome. My name is Habib Haydarian, and I'm a lead program manager in VSTS. It looks like we have a pretty small audience today, so we can have a great interactive session. I've been at Microsoft for about 8 or so years, and most of that time I've spent with debuggers. I have here with me Justin Marks, who's also a program manager on my team. And today we're going to share with you some really exciting features in Visual Studio Team System 2010 that we really think will shift the paradigm in debugging. In fact, when we were first planning out the title for this session, I wanted to call it something like Visual Studio System 2010, a paradigm shift in debugging. But unfortunately, the marketing team won out, so we ended up with a title like this. Just a couple of bit of logistics. Who here went to the session this morning that was about a lap around VSTS 2010? A good number of you. Also, I was told that if you do have any questions, please feel free to come up to the microphone, and we'll be more than happy to answer any questions as we go along. With that, let's get started. Justin and I are going to start off by describing the big picture. We're going to actually talk about the major debugging point, the major pain points in debugging today. We're going to then go through and discuss what are the sort of capabilities and features that we're providing in VSTS 2010 that stop bugs and other code defects from entering the system to begin with. That's what we call pushing quality upstream. In fact, one of the major themes in VSTS 2010 is improving application quality. So I'm going to spend the first half of this presentation talking about the set of new features that allow you to stop bugs from entering the system to begin with. Then in the second half of the presentation, Justin's going to come out and speak about, well, if bugs do get through the system, how do you actually then capture and analyze the bugs? And with that, let's start talking about the big picture. So I imagine most of you, if not all, have seen a picture that's somewhat similar to this, that basically describes what happens the longer a bug stays in the system. And the premise here is that the longer a bug stays in the system, the more costly it is to fix it down the road. Now let's talk about why that is. First of all, the longer a bug stays in the system, the more it's going to take in terms of effort to actually fix that bug. You might actually have to make architectural changes. You might have to involve a number of teams just to get that bug fixed. But very importantly, as you go from testing to staging to production, one of the things that happens is that you'll have less and less information about a bug. How many here use something like tracing or dumps to debug bugs in your production environments? OK. Wouldn't it be nice if you had the same type of information at your hands as you were doing live debugging in the Visual Studio Debugger? And that is one of the things that we're striving for in VSTS 2010. So in today's environment, we have a set of tools that allow you to stop bugs to enter the system to begin with. If you've used code analysis and starting from VSTS 2005, that's one of the tools that allow you to see what defects you might have in your code before you even run your code. Then as you get into the development or testing of your own code, we have a set of tools like the Visual Studio Debugger, as well as the profiler, that allow you as a developer to figure out what is actually happening in your running code. But one of the things that happens is that as you progress up that line and you get to the release mode, our set of tools kind of start falling short more and more. And that's one of the key areas that we're investing in VSTS 2010. But now let's talk about what else can we do to actually stop bugs entering the system to begin with. And I'm really excited to introduce a feature today that we call impact analysis that will basically show you as you're writing the code, what tests need to be run because of the code changes that you're making. So let's stop with this slides and actually get into the idea and talk about a scenario that I think is really important, and I think it applies to just about every developer. And that is, when I make a code change, what did I just break? So I'm going to switch over. Thank you. To VSTS 2008. It's great having another person here. Yeah, thank you. And I'm going to basically go through a day in the life of a developer. To start off with, I'm going to switch over to Team Explorer, and I'm going to open up my bugs. And I see that I have a couple of bugs showing there. The first one says, it looks like a code analysis violation. And as I mentioned before, code analysis is one of the systems that we have in place today to prevent you from entering bugs to begin with. And let's read the description of that analysis warning to find out more about the bug. So it's telling us that it looks like the underscore file name member is actually not used in the application. So what I want to do is I want to go and see whether I can remove some of that dead code from my application and basically check in my code. It's telling me that it's on line 33 in Patient Vitals. I'm going to switch over to Solution Explorer, and I'm going to open up the chart data project, double-click Patient Vitals, and scan down a little bit. And it looks like, yeah, there is the underscore file name member. And to do a sanity check before you make any changes that include removing, let's say, a member, it might help to do something like, you know what, I want to make sure that I find all the references here first to make sure as I make the changes, I include all the references. So it looks like I've got a couple of references. The first one looks like it's the declaration of file name, and the second one is actually just assigns the parameter to the constructor to the underscore file name. So it looks like a pretty safe fix. Let's go ahead and rather than actually removing that the member, I'm going to go ahead and comment it out. And for those of you who are aware, the shortcut key is Control-KC, and I can comment out an entire line in Visual Studio. That shortcut has been around for a long time. I'm going to do the same in the actual constructor as well. Now, at this point, wouldn't it be really nice if I actually knew the changes that are made, what impact they have on my tests? So before I go ahead and make the changes, I'm going to go ahead and bring up a new window in VSTS 2010 that we've called Test Impact View. Now, this view has a couple of panes, but the best way to really understand what it does is through this demo itself. So notice what happens when I go ahead, when I save the file. Voila. It's telling me exactly which tests in my solution are impacted by the change that I made. I don't have to guess about what the impact will be, and I can from here verify that the changes that I just made have been covered by my tests. And as you can see, there is the actual category is recommended test right now. Let's see what happens when I go and run these tests. I can go ahead and run the tests from the test impact view by selecting Run All Recommended Tests. What this will do, it'll run all the unit tests that were impacted by the code change, and I can see that, you know what, great, the change that I just made doesn't actually impact any of my tests. Now, imagine today's world where if you have, let's say, hundreds and hundreds of unit tests, you'll have to run them all, and that might take up minutes. Or you might just say, you know what, I don't have enough time to actually figure out what the impact was. I'll go ahead and just go checking the code. So this is a great way to stop bugs from entering the system to begin with. Okay, so the answer to what did I just break is I didn't break anything. Let's look at what the actual magic is that is happening under the covers as I do this. On your left-hand side is the green box is Visual Studio. And the scenario here is that I want to make a change to method M. And on the right-hand side is a TFS as well as a file location where you can drop your builds from team build. So first of all, I'm going to make a change to the method M by, let's say, introducing a new statement that increments I. What actually happens from there? Well, in order for this test impact feature to work, there are some prerequisites that need to happen first. First of all, you need to create a team build, and as part of that team build, you need to have a set of tests that run with it. So once you run the team build, we'll first publish the build, and as part of that, we'll also publish the test results that go with that build. Now, something new in 2010 is the fact that we'll also create this file or the system, the database that contains the tests to method mappings. Now, what does this actually mean? It means that we now know which tests actually cover which methods. So that later on, as you open up the solution in Visual Studio Team System, we actually take that mapping file over to the IDE, and using the test mapping file plus the changes, we can then calculate exactly what tests you need to rerun because of the changes that you just made. Okay, how many here of you have heard about the one-line change? Yes, the one-line change that you get, towards the end of the product cycle, and the developer comes to you and says, or you yourself go to your manager and say, it's only a one-line change. I swear it's not going to break anything. I promise you. And so let's look at how this test impact analysis feature now actually help us prevent that, or actually then be able to prevent the developer from introducing a defect that's as part of that one-line change. All right, I'm back in the IDE, and this time around, I'm going to just introduce a little bit of change. So first of all, the thing that I want to do is I want to add a check. So as you can see, the file name is entering the system, and there are no checks on it. So it might be a good practice to actually, make sure that at least the file exists. Since I am a lazy developer, I'm going to select the entire statement, right-click, and select the surround with command. Now, for those of you who haven't used surround with, it's basically a really, in my mind, a really good productivity feature as you're developing code. And it helps you with little snippets of code. And what I can do in this case is I can select if, press tab, and voila. It surrounds that entire statement with the if statement. And from here, you can see that the true is highlighted. So I'm going to go ahead and write my code here. So let's have if file exists. And when I press enter, it actually goes into the body. And then have an else statement that says this.create. OK. And let me go ahead and save this. You know what? The actual test impact view is telling me that nothing's changed. So I'm going to go ahead and just check this in. So right-click on the editor, select source control, and check in patient vitals. I'm going to say added a check to the patient vitals CTOR. All right, so let's go ahead and check this in. Now the tool is actually stopping me from checking in this code without having run the tests. And if we read the actual tooltip itself, it's saying the policy, the current policy requires you to run the impacted tests as part of your check-in. So let's go ahead and run the test. But I think that the change that I made should be fine. So we shouldn't see any problems. Okay. Wait. So indeed, using my one-line change, I did actually break something, right? It was the classical, I'm not going to go through details of the problem itself, but if I go back to my code, what I did was I basically reverted the Boolean check, where it needs to actually check that if the file exists, then do I read the waveform data rather than if it doesn't exist. So using test impact analysis, it told me immediately that, hey, you can actually check in this file because you haven't run the recommended tests. Again, the system actually stops you from checking in code that later on would break your tests, or even worse, go through testing, staging, and production, and actually break your application. Okay. Another scenario that comes up quite regularly is, what code have I actually changed? And you can certainly use tools like diffing, or you can scan through your code to figure out what you've changed. But with the impact analysis feature in VSTS 2010, we provided the ability to actually see what the exact method is that you've changed. I'm going to go back to the IDE. Okay. Third time is the charm. Okay. And if I go back, let me go ahead and close this test impact view. Go back to my bugs and work on my next task or next bug. The next one says run code analysis on the patient monitoring project. So I'm going to go ahead and do that right now. I'll switch back to Solution Explorer, right-click on patient monitoring, and say run code analysis. Now, what this is doing right now is building my project first, then it's running the code analysis engine on my code, and based on whatever rule violation it finds, it's going to flag them. And I can go one by one and fix the bugs as I find them. So it's showing up like there are a few of them. So what I'm going to do is I'm going to one by one go through the error list and make the changes as code analysis suggests them. So I'll comment out the unused variable. Code analysis telling me I'm going to save this file. I'm going to bring up the power source declaration that's not used as well. I'm going to comment that out. And now let's actually then simulate what happens in a real-world scenario. What I mean by that is, let's have a quick trivia. So I have here with me a lovely Team System shirt that I believe only the members of the Team System group have access to. So those of you who can answer my question can actually have this T-shirt. It's a X large, so I do apologize beforehand if the winner is not an X large. 25, all right. 42, yeah, okay. All right, so the rules of the game is, I'm going to put up the question in a second. Please do not answer the question. I'm going to select someone from the audience, and then if you can come up to the microphone and then answer the question, that would be great. So please don't answer the question. Just put up your hand if you know it. And the question is, we have John Roberts in the back, see if he knows this one. Who knows the answer to this question? All right, I'm going to select that gentleman there in the... F5. The answer was F5. That gentleman. I'm afraid. No. Okay, there was someone else in the audience here first. Yeah, we have a winner. Awesome. Come on up and grab your shirt. You want? Or do you want to throw it out?
What was the answer again?
Control-Shift F5. You can put it on eBay. Oh, I forgot I said that. I'm sorry. Okay, so the answer is Control-Shift F5. So at the very least, when you walk away from this presentation, hopefully you know how to restart the debugger. Okay, now let's switch over to our demo and go back. All right, who here can tell me the name of the methods that we've changed so far? No, there's no sure. What methods then have we changed so far? This is a great example of what happens when you're in the flow. That is, when you're developing code, right, an email pops up, you get your buddy comes into your office and says, hey, help me with this problem, or you get a phone call, right, and your flow breaks. And you have to go back and kind of rebuild the state that you were at, and then figure out, how do I get back to where I was before? So to answer the question of what methods have actually changed, well, you know what? You can actually go and use the test impact view for that. Because on the code changes, we'll tell you exactly what methods you've changed since your last checkout. So it's, again, a great way to stay in the flow. It's no longer the case of, oh, I need to go and run diff now, or I need to go actually inspect my code. You can actually do that within the IDE. Is this a cool feature or what? Yeah. Okay.
Now, what about pending changes? Would that be the same?
Right. Okay. So up to this point, what I spent the last 20 or 25 minutes on is how do you stop bugs entering your system to begin with. So I described the impact analysis feature that literally will tell you what tests have been impacted as a result of your code change. Unfortunately, one of the key problems is that it doesn't matter how much you try and stop bugs from entering your system to begin with, they will ultimately enter your system. So at this point, I'm going to hand it over to Justin Marks, who's going to actually cover a set of new features that we've added in DSTS 2010 that do exactly that. How do you capture and analyze bugs once they actually leave your environment? Justin?
Thank you, Hamid. So let's talk a little bit about some of my own experiences as a developer in the community and trying to work on my own software and debugging it. So a few years ago, I wanted to learn a little bit about C# and how some of the graphics libraries worked. And I was pretty interested in pinball at the time and was considering taking some money and buying a large pinball machine. But I said, well, why don't I combine these two interests and work on a little pinball demo app where I can just play around and learn a little bit about programming and just improve my skills and get to play with the game at the same time. So I went on the web, as many of you do, and immediately looked for somebody else's physics engine, because there was no way I was going to start off and build a physics engine from scratch, build a game engine from scratch, then start building a UI. Just, it was too much work. So I went on the web, found a great physics engine, started building my application, and as soon as I started testing, I started to see I had a significant problem. Namely that the ball, as it would start falling down the screen, would fall through the flipper. Now, this is not really what I was hoping would happen during my video game. It's not going to be a very fun game to play if I can't ever flip the ball and get it to play at all. So I, of course, wanted to hook up my debugger and start figuring out what went wrong. But take a minute and think about how you might debug that situation. The first problem, which is quite a large one to solve, is you're trying to debug an application that you're live trying to play with. That creates a lot of debugging issues to begin with. But even if you can get past all of those issues, you really don't have information about what the repro steps were. Sure, you push the spacebar to flip the flipper, but where was the ball? What speed was it going at? What were the other system variables? What had happened before? What velocity and momentum had been incurred? There was a lot of problems in trying to figure out how I would debug this problem. Wouldn't it be great if I can just get that information from the debugger, not have to worry about figuring out exactly what the X and Y coordinate of the ball was, what speed it was going at, just stop the debugger whenever I noticed there was a problem, and go backwards and see what the state was at an earlier time. Wouldn't it be great if I could, instead of putting a whole bunch of print lines throughout the application and throughout this library code, just have the debugger give me an insight into what was that dependency doing? How did that dependency work? What was happening in my own code? And not have to actually change the code to do it. That's the kind of work that we're doing with historic debugging. So to start off, talk a little bit about what does it take to debug the problem to begin with. Most of our developers today are just setting breakpoints, stepping through their application, and seeing what happened. Why do you have to do that? Why can't the debugger let you go back in time, look at previous states? Again, that's what we're doing with historic debugging, and the best way to talk about that is to demo it. So I'm going to get back into Visual Studio, clean up a little bit here from what Habib was doing, and I'm going to start off with a simple console application, and we're going to work from there. So my initial console application is a, excuse me for 1 second while I load this up, is a simple word search application. Again, going with this very impassioned game theme that I like to use. And the word search application is pretty simple. It takes in an input file, and we'll open that up right here, that gives me a grid. That basically says, I want to create a 5x5 grid, and I'm going to take these 7 words that are in the input file and randomly generate that word search. Now again, this is a random program. Every time I run the application, I'm going to get a different puzzle. Because of that, I don't want to be stopping my debugger and rerunning the app. I want to debug it when the problem initially occurs. Can you do that today easily? Do you have that information at your fingertips? Of course not. Again, with historic debugging, we hope to make that happen. So I'm just going to press F5 and run the application. Or better yet, I'll just push the start button. And as the application runs, I'll be prompted with my puzzle. But unfortunately, there's a bug. I'm not getting a puzzle. No words have been added. Something went wrong. Today, what would happen is you just start inspecting code, setting breakpoints. Forget that. We don't need to do any of that work anymore. We're just going to go into our debugger and just break right in. Yes, we know this isn't the point where the bug happened. It's just where we can see the bug. But with historic debugging, we can go back in time. And the first tool to help you do that is our new debug history window here on the right-hand side of the screen. The debug history window gives you a view of where your current state is to start off. So basically, you can see a stack. We're on thread number 4460, and we're in the main function. And this is the same data that you would see in the call stack window. But wait, there's more. You're able to do a lot more than you can with the call stack window. Wouldn't it be great if I could just go into main and see what it did? Well, that's exactly what this window allows you to do. By clicking on the main function, I'm able to see in the middle pane of that window all of the function calls that we collected beneath that main. So here you can see that we stopped at line 11, which is where we broke in. There was some constructor call, and something happened inside that constructor. And then also some work happened in external code. External code being code you didn't write, things like the .NET framework or maybe a library that you've downloaded would have had. But I can keep on going. Not only can I see where main or what main did, I'm also able to go into the constructor and see what happened there. So if I double-click on the constructor, it moves to the top pane of the window, and now the middle pane gets updated relative to that constructor. It's sort of like the choose-your-own-adventure model you could remember when you were a kid reading a book. You're choosing which call stack you want to look at across the application. And now we get a lot more information that we couldn't see before, namely that inside the constructor, some sort of exception occurred. We could have figured that out if we had stopped the application and turned on first chance exceptions and done a whole bunch of more work or pulled more tools off our shelves. Now that information is just right at your fingertips during your debugging session by default. This is just going to happen. You don't have to turn any settings. You don't have to turn anything on. It just works. But you can get a lot more information. Because we have access to all the external code and the events that happen there, I can drill in a little bit more to find out not only where the exception was caught, but hopefully where the exception was thrown as well. So if I double-click on the external code, I'm now presented with all of the events that took place inside your external code. So let's just take a minute and talk about what these events are. Diagnostic events, the term we're giving to events that occur during external code or during framework code. Places we're going to put these events are things like file accesses, registry accesses, ADO.NET calls, and all the other platform tools that you use. We're going to add all these events, so whenever they occur in any application you're running, you'll have insight into how those dependencies work. Wouldn't it be great if next time one of your database applications fails because of a timeout, some sort of network latency problem, you didn't have to investigate, is there something wrong with my code, and just got an exception that, or not even an exception, an event that you made a call to a database, this was your connection string, this was the commands you passed, and you got a timeout. It'd be a lot simpler to debug those issues, especially when we're talking about enterprise-level applications. In this case, we can see that a file stream event occurred, namely that it was trying to access this file word search input, which is what we expected. That was the file we passed in. And we can also see that an exception was thrown. The exception says that, and if we look here in the details pane, we can get a lot more information about what that exception was, and we can see that it couldn't find the file. And basically, if I investigate this a little bit, I'll see that the file isn't in that location. Some sort of deployment step failed. How many people have had that occur when they're building enterprise applications? That you somehow do a deployment or expect a tester or some other member of your team to do a deployment, and you missed a step or something didn't occur, and you really want to debug that. It's a common problem. Now with the debugger, you're able to easily find that root cause and figure out what went wrong. So now I'm just going to fix that problem. I can look here at the word search file and see that it wasn't copied to my output directory. Pretty simple fix. And I can rerun the application and see where we're at. And sure enough, now I'm able to get a word search. But now I have a different problem. Yes, I'm getting a word search, but it's not working. The words that it's listing here, seed, hello, world, donut, aren't anywhere in that puzzle. So here's another bug that I want to be able to solve. But what's interesting is, let me just take a step back and talk about how I wrote the application, because that might help you, as well as me, form a hypothesis of what went wrong with the bug. You'll see that there are some letters that are lowercase, and some letters are capital. The way I wrote the application was, after randomly trying it out, if I want to insert a word, I insert the word in all capital letters to help me identify that it was the word that was inserted. And then I filled in the grid with random letters when I was done. So I have some insight that there are 4 letters throughout the puzzle that are capital, which all match the 4 words that I tried to enter. So maybe something went wrong inside my insert word function. Why can't I just go back in time to the point where insert word occurred and see what it did? That's what I really want to do. That's what you're doing by setting breakpoints and rerunning the application. But you don't want to set those breakpoints. You don't want to rerun. You don't want to step through the application again. You just want to stop the application at this point and go backwards and figure that out. So let's try to do that. Again, we're going to break into the debugger. We get our debug history window, which has all of our data. And we're able to start investigating what happened inside main. But if you look closely, there's a very limited set of information here, namely the information that was related to those diagnostic events. This is what you see by default. In this case, we want more information. What we'd like is to see all of our function enters and exits. We'd like to see local variables. We'd like to see parameters. Of course, historical debugging has this functionality, but we didn't turn it on by default. We wanted it to be very low overhead from the get-go, so it's a part of every debugging session. And then you can turn up the dial and collect more information when you need it to help debug. So if you click on the settings button right here in our toolbar, a settings dialog will come up that allows you to tune or change what the collection settings are for historical debugging. So at the top, of course, there's that infamous way you can turn the feature on or off. And then below that, there are a couple settings. By default, as I said, we have the events only mode. But in addition, there's this new mode for methods and parameters that will let you get every function method enter and exit, and of course the call sites as well, collect your parameters, your locals, your return values, lots more information. And of course, that's not the only setting. There's a lot more. We have a custom mode that allows you to tune a little bit more, and you can choose how much data you want to collect. We have the ability to choose where we would store our recordings. So if you want to put those in an external hard drive and not fill up your C drive by default, you have that power. You can decide how many logs you'd like to store, because of course, one of the great features you'd like is to be able to compare the log from this debug session versus the log from the previous debug session. You can decide how many of those sessions you want to retain. And you can also choose if you'd like to truncate the log and limit the size that the log could possibly occur. That also will help with space savings. But for now, we're just going to set it to the methods and parameters and restart the debugger to take those parameters into effect. So now we rerun the application, and we're back at the same point. We still don't know much about what took place, and we're going to break in. What's changed? So right away, you can see in the main function, let me just increase the size of this window so you have a little more visibility. you can see that you have your parameters shown for the function in question, and for main. And when you click on main, you'll also see that there are two new functions, fill and display, that occur underneath main. These are the two functions that, if you looked at the code directly, were called from inside the main function. And of course, you can drill it through using this window. You can drill into every one of those functions and basically see the entire execution history of the program. But if we just hover on fill for a moment, we'll see that there's 1,993 calls directly under fill, not even including the ones that are 2 levels deep. That's a lot of information to sit there going step by step and looking. This is really not the best way to navigate that information. What you'd like to do is go from code. We had a hypothesis when we started this demo that there was something wrong with insert word. Why can't we just go to that function and just say, I'd like to do a search and find out what information there was in historical debugging about that function? That's exactly what we can do. So we're just going to make this window a little bit smaller so we have a little more room in the editor. And we're going to scroll down to the point where the insert word function is called. So we get that point right here. And we're going to right-click on the function and say, search debug history. Now, as we search debug history, we'll see that a dialog opens up and immediately starts a search across the entire log. This might take a few minutes. It might be very quick. It depends on how large that log file is, of course. And we're able to see that there are 4 instances of this function being called in our application, which matches our expectation. There were 4 words added to the program. And by clicking on the first instance, we're able to jump back in time, leaving our current debug session with our live instruction pointer and moving back to a historic point in the log. Remember, we're going back in time here. It's a lot like using your PVR and clicking the rewind button. We're just going back in time to figure out what took place inside the application at a previous point of time. And if we look at our editor, of course, we're now at the point where our IP is pointing to that new line we wanted, basically insert word. And what's also interesting is that the IP has changed a little bit. It's no longer that yellow or green that you're used to seeing. It's now a blue representing historic mode. And you'll also notice that to the right of the IP, there's a new navigation gutter. This is a new function that we've added, or a new UI component, that allows you to, from the editor, from where you're already working on your code, start navigating. Just like you could use your similar F10, F11 functionality today, you can start using the buttons from your editor. Step in, step over, step back, all those functions that you hope to have work. So let's do that. We'll first step into insert word. And now we're inside that function, again, at a historic point, the first time this function was called. And all the functionality that we're used to using with our editor in a live debugging session continues to work in a historic debug session. So what about data tips? Absolutely. We hover over the word to insert, and we can see that the word to insert was seed. Same thing with word position. We can see that it is a class, not just a primitive, and we can expand that class to see the first level information, that it was inserted at 0.11. And of course, the locals window and the call stack windows in your editor also are updated to reflect this information. Same with your watch window. So you're not learning any new tools. You're just using the tools you use for live debugging, but with a historical point of reference. And you didn't have to do anything else to get this functionality. It's all there in the IDE by default in Visual Studio. So let's get back to trying to solve the problem and figure out what went wrong and why insert word failed to insert those words correctly. So I'm going to step through the application and see if I could figure out what went wrong. So of course, the first word, as we saw, was seed. That was the word was being inserted. And it was being inserted at 0.11. So just using my simple math, I know that the S would be at 0.11. And since we're putting it in the direction of right, the E would have to go into the X value of 2, Y value of 1. The next E would be in 3, 1, etc. And so we got all 4 letters inserted into the grid. But as I walk through and step through the debugger, I can look and see what the return values for those get X, get Ys that I'm doing inside of this grid position. And if I click on them, I can see also in the debug history window, again, we're able to use both of these tools, both of these UI components synchronously, and we're able to see the same information in 2 different places. And we can click and see all these get X values always return 1. When I wrote this program, I never took into account that I had an iterator, and I was iterating through multiple letters. Every time I entered a letter into the grid, I put it in position X, Y. What I really wanted to do was adjust for that increment, saying, okay, I need to add 1 or add 2 based on which letter I was adding. It's a very simple mistake. It's something we commonly do when we're debugging, we're developing code. It's just something that we had an oversight. But with traditional debugging, it would have been a much harder problem to solve. It would have been harder to validate our hypothesis, and it would have been harder to fix because it would have taken so much time just setting up the repro, just setting up the environment, just getting to the point where I can even figure out a fix of the code. Historic debugging simplified that into 5 minutes. So I'm going to stop my debugger session, and I'm just going to make a quick adjustment and take into account our adjustment for x. So we're going to make an x adjustment where we take the word direction and our iterator, and we'll do the same thing for y. And now we'll, oops, word direction, I. And now when we rerun the application, we're hoping that it's going to fix the problem. And sure enough, we're now able to get a valid grid that has 4 words added to it, and all of the words can be found. So seed is found. Where is the found? There we go. Wait a minute. Oh, wait. Hello is found right here. Donut is found here. And actually, there's another bug. So seed should have actually been right here, but there was some other problem. So again, we can use historic debugging to bug through that. We're not going to do that right now. We're just going to move on and talk a little bit about how historic bug debugging actually works and what's happening underneath the hood here. So we can get back to the slides. So what's going on? Well, the first thing is we have to decide what we're going to collect. And historical debugging does this inside of a collection plan. This is a simple XML file that you're able to put on any box or share with other coworkers that describes what we're going to collect. All those settings you saw inside of the settings dialog are stored in this place. In addition, there's a description of all of those diagnostic events and what data queries you'd like to do from those events. This collection plan is then loaded up by the debugger as it's starting to run and is used to tell the debugger what information to collect. For when we want to collect all those method enters and exits, we're using the iCore profiling APIs that are used by the profiler to instrument your code and put all those hooks inside to get more information. That's how we're able to collect all that extra goodness. And for all those diagnostic events, we're able to use hidden trace points to basically break the debugger, collect some information, and then continue execution. Correct. And we'll talk a little bit about how we can do this in some other places as well. And that's the second half of the talk. So all this information, there's a lot of information flowing here, and we store all of that in a log. We spin up a logger at the beginning of your debugging session, and all the information we collect is stored in this log file. This log file is portable, meaning I could take that log file from any copy of VS, send it over in a bug, send it as a file share, send it as an email attachment, and then open that log file up in another instance of VS and debug right from the log without having to send over the application, without having to set up an environment, without having to set up bits. I just started the bug session from a log file. This is a huge win for team development, where multiple people are needed to fix problems. Finally, all the information that we've collected is shown in the common user interface of Visual Studio. So again, you don't need to learn a new tool. All the information you need, all the tools you have, all the learnings you've had from using the debugger in the past are able to be applied to our historical debugging. It's just another tool in your handbag as part of what VS provides for you. So we've talked a bit about how a developer would handle this in the F5 case, using their debugger in the part of their debugging session. But what else can historic debugging do? What about the test scenario? What about all those times when Cameron spoke earlier today about that no repro? When a tester files that bug, and they don't quite get enough information for the developer in their first instance of that bug, they send that bug over the wire to the developer, and the developer says, you know what? Doesn't repro on my box. It's not a problem. And they just resolve it in no repro. And then there's basically a battle or a ping pong effect between test and dev. All they're trying to do is not to battle whose bug it is, but get the right information to the bug. Why can't historic debugging collect this information during a test run and provide that right from the beginning? That's what we're able to do. By making a data collector and installing that as part of the test suite of tools that Visual Studio provides, you're able to get this data during any test run. And again, you're able to make all the configuration settings that you would have chosen through F5, but just from a test run. That's a lot more power. That leaves the developers, the testers, more time to file more bugs and find other issues as opposed to being reactive to the developers and just getting more information on the same issue that they already know occurs. Do you have a question? Or? It could be a release build. As long as you have symbols, you're in good shape. So let's look into that, and let's actually do a demo of what it would take for that gapping of the development and test organizations and seeing how we can use historical debugging to help our testers. So we're going to go back into our demo machine, and I'm going to close up Visual Studio for a minute and open up Kameno. Now, Kameno is the new tool coming out of the Team Test SKU, or the Team Test part of the Team Suite. And it's basically an interface for testers to be able to start testing. Now, we're not going to go too much into how the tester works and what they're able to see. There are other talks that are taking place here, as well as the walkthrough that you'll get as part of your hard drive, where you can walk through and learn much more about the testing tools. What I want to spend our time talking about is, how do they actually do the general work? How are they able to, once they have all of their settings and all their configurations in place, do a test run? So for this demo, we've already created a test run to begin with. And of course, historic debugging is enabled for that test run. And we're just going to start that test run here and run through a test case as if I was a tester. So I've got my tester hat on here. So we start our test run, and we're just going to dock our manual testing view to the left-hand side of the screen just to get it out of the way. And we're going to choose Test just to start testing right from the beginning. We really don't need our video or action logs. That might be useful for some organizations, but for our demo purpose, we don't really need it. And off we go. So if we look at our steps, the first step is to open the Dinner Now website. Now, you saw a little bit about the Dinner Now website earlier today, but for those that weren't at that talk, let me give you a little description of this. Basically, Dinner Now is an online food ordering service where you're able to go online, search for a restaurant of your choice, say, I want to buy a cheeseburger and a milkshake, and have it delivered to your house. And it's just a simple web interface. They also have a WPF front end, so we could be debugging from that. But for the demo, we just chose to show what it would be to debug through IIS and IE. So we've loaded up our website, and we can mark that first step as a success. The next step says to click on the Testimonials tab on top of the page. So just go inside of IE and click on Testimonials. And I should get a page, but instead what happens is I get an exception. Now, ASP.NET does a great job of giving you information about what the exception is that occurred. And normally, that's enough for a developer to fix their problem. But let's take a look at this exception for a minute and see, maybe we can just fix it right now and tell the developer in the bug exactly what went wrong. And taking a look, we can see that an error occurred while parsing entity name, line 10, position 53. Well, that's pretty helpful. I know it's on line 10. I know it's character 53. And if I look a little bit in my call stack, I can see that it is indeed referencing some sort of XML, which sort of matched my expectations from using the term entity name. But where in all this information that it collects does it tell me what file it's referencing? That's a bit of a problem. How do I know what the fix is if I don't even know what file they're opening? I've got a line number, but that's really not enough information. So this is better off for my developer to fix. So I'm just going to file him a bug. So I click on the File a Bug button. And what's happening now is we're going to the IIS server. We're taking that log that historical debugging collected. We're uploading that to TFS and storing that. And we're attaching that to the bug. So now, once I file the bug, not only does the developer have the set of repro steps that I used because it was a test case, they also have that extra tool of the bug itself. So something went wrong there quickly. So we're just going to restart that application and just do it real quickly. So bear with us for a second. Excuse me? So we're going to get back with you. We're going to get you right on the right track here. Again, these are CTP bits. We are still working very hard on all these problems, and by the time it releases, we're going to be in pretty good shape.
That's okay. Justin's just building up the suspense right now.
Exactly. So we'll quickly run the test again. We don't need any of these settings. That's great. We'll open up Dinner Now. Dinner Now is having some real fun today. Sorry about that. It'll just take one more minute. So some of the interesting things that we could talk about here is, first of all, what am I debugging? I mean, one of the common questions that I've gotten about the scenario is, does it have to be a local host? IIS happens to be running on the local box, but what about if I'm in a remote scenario? What if I have multiple servers, multiple clients? Am I able to collect logs from both the server and the client? Absolutely. If this was a WPF front end, I could have had one log for the client application and another log for the IIS application, which allows me to have a lot more power as a developer and be able to mash together what my multi-tiered application is doing. So we're going to try this one more time. We're just going to copy the file name, mark the test step as failed, of course, create the new bug, which is going to upload that log file. And then we're going to hopefully be able to file a bug. Great, it worked this time. So we click on title, and we're going to just paste the title. And Kameno's already taken care of the rest for me. It's taken care of attaching the log file as a link and already filling out all the details and all the system information and all the other information that's pretty much just busy work, so to speak. So it's still, you can see that it's still uploading and linking the attachment, and now the log is there. And if we click Save, we can see that we have a new bug number 289 that has been filed against our developers. So we're going to close up Kameno now. And let's just take a break for this and think about what we've done. There's been a lot of stuff that we saw, and all of that's this tester's case. And maybe some of you are testers, but most of you are probably really interested in what is the developer experience going to look like? What happens, like what Habib showed in his demo, when the developer comes in the morning and sees a bug on their plate? So let's just go through that scenario now. I'm taking off my test hat and putting on my dev hat and going back into Visual Studio where I'm comfortable. And I'm just going to go to Team Explorer and see what bugs happen to be on my plate for today. So we go to Team Explorer, wait for it to connect to the server, get my list of work items, of course, and I'm going to run the query that my manager has set up for me of basically what is today's list of bugs for me to look at. And the query basically is, what are the bugs that were filed within the last 24 hours? And if you look, we're still seeing bug 289. This isn't a pre-canned bug. This is the bug that I just filed. And of course, as a developer, I can look through all this information and see all the details about what took place. I can look at system information and find out all the information about the box the log was collected on. And what I really want to do is I want to start debugging the problem. I know that some sort of exception occurred, so I'm just going to double-click on my log file, and I'm going to open up a summary page showing me what that log has collected. Now, this looks a little bit rough right now. It's pretty simplistic, and it basically starts out with a list of threads. But over the course of the next bunch of months until we release the next version of Visual Studio, we're going to be adding a lot more information to have at your fingertips. Not only are you going to have a list of threads, you'll also have lists of modules. You'll have system information about the box it was collected on. You'll have the ability to search through all the exceptions and events that occurred in the log. You'll have all of those test steps. All the different places you might, as a developer, want to start a debugging session will appear on this page, and you can just launch a debug session from that log to the point you want to start debugging. In this case, we're just going to launch a debug session to the beginning of the thread. So we double-click on the thread. The log gets loaded up as a debugger host, and we start up a session with it as the baseline. And we can see here through our debug history window again a list of events that were occurred and different things that took place in IIS. And I know that testimonials.aspx was the page that had the problem, so I'm going to drill into that method and see what happened inside that function. And I'm given a list of 11 events that occurred inside that function. Now, one event that I get here is the pre-init, basically giving me a contextual point of reference to let me know as the developer of where I am in my code's execution. Basically, I'm initializing a page. I can continue going through this list of events, seeing that the file itself was opened, that I got some sort of initialization complete event from ASP.NET, that it loaded that web page into ASP.NET, and then that it populated an XML file. Let me open this up a little bit more so you have more room to see, called appdata-whack ads.xml. Well, that's starting to give me a little more insight on what that XML file was that I was having that error from. And then I can see a create event for the full path to that file. And then, of course, there's that exception both being thrown and being caught. So all the information I wanted was available in this log file. I didn't have to open up any of the tools. I didn't rerun the app. I didn't look for source code even. It was able to use Visual Studio to get all the information I needed right from the beginning. And now I'm able to make a quick fix. So I know what the file is, so why don't I just go on to pretend I'm on my server, and I'm just going to go to my recent files where I actually have that file already preloaded, and pull up that XML file. And if I look at the XML file on line number 10, I can see that there's some extra characters that really shouldn't be there, and they're underlined, and I can get more information from the errors that that entity wasn't defined. So let me just delete those characters. Pretty quick, pretty easy. Save the file. And let me just try refreshing that website. Now we're able to see that the whole web page is now working as appropriate. Think about how easy that was. We didn't build any environments. We didn't do any setup. We didn't do any reproducing of the bugs. We were able to fix everything with the tools that were given to us right from the beginning. The tester gave us not just a bug that was actually causing our users problems, but they were also able to get us all the information we needed to solve that bug. How often does that happen on the first occurrence in your organization? How often do you have everything you need at your fingertips where you can just get into what you want to do, what you're paid to do, debug the problem and fix the code? We got rid of all of that extra busy work. In addition, this was an enterprise-level application. This wasn't some simple console application that we started the talk with. We're able to do this for a whole multitude of applications, not just IIS, but also for web services. You're able to get information from a whole slew of platform components. We just saw what it was like for ASP.NET. WCF, yep, we collect all that information. If you have WPF code or WinForms or web forms applications, all the common technologies you're used to using, we're able to collect that data and give you not just the contextual information or contextual events about what took place, but all the information that happened behind the scenes that you really didn't have much insight to before. So, we've gone over a lot today. Habib started off talking about how important it is to fix the bugs before they get into the product and ensuring a certain level of quality in your application by validating and testing and ensuring quality of test runs before you make a check-in. And then I went in and started talking about, well, we know some of those bugs actually do make it into the products. We know bugs are bound to occur. But now we have a better set of tools as developers to help us fix those problems. And not only is this a benefit to developers, but testers actually get a bonus too. They're not spending their time responding to dev. They're spending their time doing what they want to do, breaking the product, finding the bugs, defending their customers. And everyone's able to work more efficiently, faster, and all of this is because of Visual Studio. So, there's a lot that we went over here. I know both Habib and I went pretty quickly through our demos. We do have hands-on labs that have been designed to mimic the exact same demo. So if you go into the hands-on lab, I believe they're the yellow computers on the left-hand side of the convention center. You're able to go through the exact demos at your own speed. The one that this one covers is the TL-HOL11. And don't worry, I've got a little pamphlet here that's got all that information as a cheat sheet. And feel free to go through those at your own speed. Of course, those will also be in the walkthrough. So when you get your hard drive, you can walk through both of these scenarios. And we'd love to get your feedback about those. Also, there's a whole bunch of other sessions that are really interesting for developers to talk about. A couple that we'd like to highlight is that tomorrow, John Cunningham is going to be doing a lunchtime discussion on debuggers, tips, and tricks. On Wednesday, Robs will be doing a talk on improving code quality. And then on Wednesday afternoon, Steve Carroll and Ed Glass will be doing talks on performance and improving the performance of applications. So we hope that this was a good introduction in what the next version of Visual Studio Team System has. We're definitely open to questions, and also we ask that you fill out your evaluation sheets. So thank you very much. So if there are questions, we ask that you come up to the mic so we can make sure that they get recorded as well.
The sessions that actually I could probably talk about. The sessions tomorrow, or those sessions that you introduced, are any of those 2008 specific, so that there's stuff that we can use right now, or are they all 2010?
I'm pretty sure that John's talk for debuggers, tips, and tricks will be a little bit of 2008 and a little bit about what's coming, and same from the code quality standpoint. So you'll probably get some benefit out of that. Performance, we'll talk a little bit about what's in 2008, but also, again, show a lot of the new functionality we're making in 2010.
All right, thank you.
All right, there's no more questions. We're going to be around if you want to ask or anything. Thank you.
I have a question.
Oh, sorry.
Yeah. The tracing that you're doing,
yep.
The log files that you're generating when you're capturing it from like both the server side and the client side, can you actually walk through the log and step from the origination transaction into the server side transaction?
So we don't have correlation in our current product. It is a feature we know we'd like to be able to do. What we are allowing is for you to open up both logs at the same time and step through each. But we don't have that linking where it says, OK, I made the jump across the wire at this point. But it's definitely a piece of functionality we'd like to add in the future.
Great. Thanks.
Let's bounce back to the other one.
Oh, there's more over here?
I think that gentleman. Did you have a question? Or?
Hi. This tracing functionality I assume that's to be used just in testing environments, or you are suggesting that there's also be enabled on production all the time?
So we are definitely
Or
working
you can
towards being
just
able to reach
enable
production.
and disable
For
one time?
our current plan, we don't intend this to be used, and having Visual Studio at all times hooked up to your IS servers in the production is probably going to give you a performance degradation you wouldn't really want to have. But we definitely want to work towards that vision of being able to complete that dynamic IT and allow you to get these logs on a live server and be able to then have the developer debug that offline.
Or maybe just the binaries are being instrumented and deployed on the production, and you can control where
Absolutely.
you can generate the logs around.
Yeah. Again, our V1 is focused at being able to take Visual Studio and hook that up, and then also in a test run. We aren't going to provide that for production. But we definitely want to get there in the next couple of releases.
We'll need a lot of time to harden the product for the server in production, and we want to make sure that we take kind of like baby steps. You know, developer and staging server for V1, and then in the future, it's definitely a direction that we're going towards.
Thank you.
Thank you.
Just want to check, do you actually store the security context as well?
When you say security
Yeah.
Like,
context,
who it's running as? Like, yeah, that's sort of like often the trouble when you're debugging is that you can't open something access denied and it's, well, who's it actually running as?
We don't have that point in today, but we are definitely working with ASP.NET to define what those appropriate points is, and that sounds like a really good idea for something that we want to collect. Nothing is preventing us from collecting that. We just don't today have that point. But we'll be defining a new set of points between now and the time we ship. So that's a really good suggestion.
One thing we didn't cover is the whole system is very extensible. So if we can't, let's say, add those extensions, we're going to provide essentially an XML experience in version 1 where you can go ahead and add those extensibility points yourself. So unfortunately, there's just so much more to this talk that we were only able to scratch the surface.
About data collection on the bugs that the testers are finding, how about data collection on an actual mobile device? If I'm testing it through ActiveSync.
So we're not supporting any of the smart devices today.
Okay.
Our first version.
So I'll have to use the emulator.
Excuse me?
I'll have to use the emulator
Yes, exactly.
for now. Okay, thanks.
With the auto-filing of the bugs in Camino, using the tracing, does it attempt to stop duplicate bugs from testers?
I'm sorry, I missed.
Like, so you, for example, showed the dinner now, right, that 4 testers could have hit that, and then at that point filed 4 bugs on the exact same thing?
Yep.
Oh.
So you can definitely file multiple bugs, and we have a single instance of that log file on the server at that point of time. If you, on the other hand, say, let's say, okay, well, that first screen, it worked as expected, but I still want to file a bug because maybe a string was incorrect or an image was offline. It'll take a snapshot of that log, continue collecting for further logs, and then at that later point put a new log out there saying with the additional functionality. So there will be a duplicate of that first portion of the log file, but of course we're going to optimize putting the right files on the server and not waste space wherever possible.
But if your question is, do we do any smart analysis? For example, to say, here's the actual call stack in log file A. It's the same as log file B. We don't have any plans in V1 to make that kind of optimization, but it's certainly one of those things where we can do that in the future.
Okay. Thanks.
Question. Does all this stuff you talked about work for C++ as well as C#? Or
For all managed, well, managed C++, managed C#.
no, non-managed.
Yeah,
We're
we
talking
aren't working
non-managed.
for native in our first release. It's, again, something we want to hit, but
Then it's
not
not very
gonna be in
good.
our first
Unfortunately, 99% of code now, at least in my world, is not managed at this point. And
It's so easy now to split the speech. It's not to start listening.
that's a whole other discussion.
well, when you have millions of lines of code written, it's hard.
We
It's hard to
fully
convince
understand
people.
there are many of our customers that would like this in native code, and we want to be able to enable that.
The other question is, as far as you were talking about testing on platforms and all this, what kind of down-level support are we talking? I assume this is going to require .NET, some version, probably a very recent
.NET
version of that.
2.0 and above for all the so it's a .NET 2 application, .NET 4 application we will be able to collect. And from a platform perspective, you need to have Windows XP SP2 or later.
Oh, so it's not going to work on 2000 or 9X at all? None of this stuff would work? Even if your app runs on those, it's still the data collection isn't going to work?
You can try it. We aren't supporting those things. We aren't testing against those because those products are out of they're out of not out of commission. They're out of life at this point, end of life.
That's not good. I like the sound of it, but the rest of our users may not agree with you.
Agreed, but of course we have platform components that need to work, and if they don't work, then we can't work either.
I understand. Thank you.
Thank you. Is anybody on this side? Okay.
Just another one. Just how bad is the performance when you're capturing the sort of the actual
Again,
parameters?
it depends. It depends on how the application runs. How bad is it in the CTP? Worse than we want to ship with. So if you see performance degradations or specific problems, expect those to get resolved to some extent for ship. But of course, we want to get as good a performance as we can. We want to be able to reach that dynamic IT space in the future where we can be on a production box. So performance in everything we do is very important to us.
If I can add to that, the model that we adopted is the pay-as-you-go model. So by default, we hope, since you're not specifically telling us to collect X, Y, and Z, we're hoping that you pay very little. But if you want more information, you'll know when you're going to essentially make the app go slower because you told VSTS, I want to collect more information. So Justin referred to turning up the dial. We're going to make it a very explicit user action rather than us, some magical way.
And if you think about like the test scenario where we brought the Dinner Now application, that website was incredibly responsive. There wasn't any major overhead that you saw, and we were collecting that default level of information. It's when you want to collect more information, and you know what? I don't really mind as I'm trying to do debugging in my desktop if the performance goes down a little bit, if I can get more information.
Yeah, it's just that there are other libraries around that do sort of historic debugging. And I think they've been unused because they've just killed performance so much. I can't remember the one I'm thinking about. I thought it went through a massive amount of optimization, and people are saying you can actually now use it.
I think it goes back to, we understand, like people do tracing today, right? They call it not printf, and the more information you collect, obviously, the more you're going to slow down your application. The model that we're going with is exactly that. So by default, I'm just going to throw out the number right here. Is let's say by default the overhead is going to be between 8 to 10%, right? But as you turn up that dial and say, now I want you to collect method enter and exit and parameters and so forth, that's certainly going to hit up your costs. So when we've talked to customers, for example, we visited with a couple of very large web IC customers, and what we heard was that they're more than happy, for example, to take off a production box from production, run the historical debugger on it, collect that log file, and be able to analyze it. So there's certainly a number of different scenarios that you can think of where, you know what, it's okay to pay that overhead. But I'll go back to my point is we want to make it a very explicit user action, right? No magic under the covers.
Cheers.
One more.
Sure.
Just an idea, but it would be very nice if we have some mechanism to automate the activation or the activation of the generation of these trace logs.
Mm-hmm.
Like we detect some condition or exception or threshold or something like that, and then we run some script to automate that. That would be
absolutely
really, really very nice.
And it's definitely things that we are currently investigating how we would make that happen.
One quick question. 2010?
Mm-hmm. We have not made an official release date.
Where's that marketing person? Is there anyone?
Where's Doug? Doug, anywhere in the room?
Right now, it's
we have no release dates at this point.
We just build it. We don't know anything about dates. That's all we do.
Thanks, Steve. Sure.
So, just out of curious about how you're going to be publishing these results. I'm guessing that as you're collecting this log information, it gets published with a test result to a build? Like currently test results get published to a build?
It's just a test result. So
okay.
We use the TFS functionality to upload that into the TFS server with if it was a snapshot or a picture or the video, the same mechanism is used.
So it would all still be tacked onto a team build and a build machine somewhere. Is that still going to be a mechanism that uses a file share to do that?
So I want to make sure that I understand. Are you referring to the first scenario of where you had test impact, or are you referring to the second scenario where you actually had the log files and you're asking where are you
Well,
storing
like the
those
scenario
log
where you're
files?
creating a bug, right? And
Right.
you're creating a bug work item, and it's going to have the results all published to that bug. And obviously, if I'm on a different machine somewhere, like I'm the developer now, and I'm capturing that, looking at the test result that the tester has published at that point, I'm guessing, right? Because they're looking at the bug. Is it attached to the bug work item and now in the SQL server?
It's actually not an attachment. It's a link.
Right,
so
okay.
it's stored in the SQL database, not in a file share.
The test results
The test results are all stored in the database. There's actually a separate database inside of TFS for those test results.
Okay.
And this is obfuscated away as something in there.
Because the current version of the T Foundation server, one of the problems we're having is that our testers are actually working outside the firewall. Yeah. And so we've got a distributed development team, and so some of them are, but some of them aren't, and so they're unable to publish test results because they can't access the share of the build. And so when you go to publish a test result, you have to pick the build, and they try to do it, but of course,
I know
without VPNing
for
in and
a
connecting.
fact that we are not on a file share anymore. As far as those firewall issues are concerned, Brian Harry is probably the right person to ask about that.
Brian
Harry, and I can talk to you, and we can get you in contact with him to get the answer.
Yeah, that'd be great.
But definitely something we'd want to take into account.
So fundamentally, it's a permission issue with TFS, you're saying?
Well, no, it's just an architecture issue in terms of the infrastructure. Because right now our testers aren't on the network. They're so and TFS has been great because it's all HTTP, except for this one thing of being able to publish test results.
So we can double check that, but I'm pretty sure that we've been taken care of. We'll talk afterward.
Thanks.
Hi. So I'm coming more from a test approach because I do a lot of testing, and I've had that problem too. But the one thing that was really exciting to me is when you're a tester, one of the things you want to understand in any particular build is that the coders have made a certain number of changes, and we don't necessarily want to do a full regression test every single pass. We might only need to touch a certain number of things, and so we can iterate quickly and get that information back to dev. So you have that one thing that shows the impact. Is there any way to potentially augment that so that my functional tests or my automated tests or things like that, is there some way to get that same kind of relationship? I understand kind of how you've put that together on a method basis.
How do you test prioritization based on a build to build?
Yeah, because I mean, we can do this on change sets today. We can sort of kind of say, well, we can understand from where the developer's been, make some kind of estimations. But if that would be somewhat of a holy grail for QA to have that kind of relationship.
So the Camino UI that Justin very briefly touched base on is that there will be essentially a panel or report that shows you exactly. So I showed you the developer view. There's a whole different experience for a tester where you as a tester can see from the last build what changes were made and only run those changes. So you talked about optimizing. What's that, sorry? What tests were changed? Yeah.
So that would be
great. I think it gets us a little bit there in terms of what your scenario is.
Yeah, I was just thinking that because you had based it on it looked like from the developer's perspective, it makes logical sense that you could easily tie your unit test by method. But I was a little bit concerned that our functional tests like order tests and things like that would not be so easy to map to a method. So, but that'd be great if it has it.
Thank you. Any more questions? So we're going to be around after if you want to just come up and say hi.